Hello, my name's Humphreys. I'm a student at Charles Darwin University studying a Bachelor of Exercise and Sports Science. I'm a keen exercise and sports participant myself, particularly around triathlon. Last year I competed in the World Duathlon Championships, and this year I qualified for the World Cross Triathlon Championships. So today I'm going to talk about the use of technology in sports, in particular from a point of view of a biomechanist. So I'll talk about the advantages in using technology, the disadvantages of course as well, and give a balanced review at the end. The technology I've decided to use is a GPS watch. The particular model that I have here, it's a Garmin brand GPS running watch. It's a Forerunner 910 XT, used often by those that compete in triathlon. So the reason I've chosen GPS watches as the technology to review today is that they're widely available. Most people have them, even recreational runners. If you look around, you see most people wearing a GPS watch these days. They're relatively inexpensive at around $100 or so, which is probably why most people have them. And they're packed with a whole raft of additional features. For example, not just recording speed and distance, of course, but heart rate. You can use them for training zones, interval training, and a whole heap of other data as well. You can also record, log and record the results online for review later on for yourself, or coaches and the like can get on remotely and have a look and see how you're going. The particular aspect I wanted to speak about from a biomechanist point of view is stride length. And stride length's that distance from one footfall to another. It's of particular interest to biomechanists because it relates to running economy. So being able to compare the stride length versus compare the stride length, for example, between sprinters or middle distance runners, or for the same person, over a 3 or 6 month training period, to see if there's been any changes, whether that might represent improvements or other. You can also compare on different terrains, so hilly or undulating terrain versus sort of flat running ground like a track. And of course, it could be a good indicator of fatigue as well in long, particularly long races, particularly in, say, endurance events. It also can change relative to a runner's leg length, or would change relative to a runner's leg length. So there's a lot of different sort of facets to stride length that can be taken into consideration, and I think that the GPS watch is a good tool for that, and I'll explain in detail a bit more why I think that's the case. So I think the main advantage in using a GPS watch to help measure stride length is that it can be done anywhere. So you're not reliant on a fixed distance track, for example, a 400 meter track. So there's no special access needed to a facility like that. You could be running on the beach, up in the mountains, or just running through the streets or in a park. All you've got to do is just when the runner gets into their rhythm, press start, count the number of steps, run for a reasonable distance, sort of maybe 100 meters or so, and then when they're ready, press stop and just note down the number of steps. Look at the GPS watch later to work out distance, and then they can work out the stride lengths from there. Of course, the longer the distance they can do that, the more accurate the stride length will be. And as I say, they don't need to specifically be running on a set track. That also means that athletes free to just run their normal rhythm. They're not thinking about having to start exactly at the start line and sort of stop counting exactly at the finish line. They can just relax into their rhythm, and once they feel they're in the rhythm, as I mentioned, hit the start button and then stop at the end, and then look at the numbers later. GPS watches aren't without their downfalls though, and a worthy comment would be, how about if I haven't got access to a GPS signal? So if I'm indoors training, for instance, like I'm in a gym, inside a concrete building, then I probably haven't got access. So what do I do in that case? Well, that's true. You want to measure stride length or any other parameter that includes distance and calculating speed. then it's not going to be useful at all. I suppose the watch itself, the technology, can still be useful for its other features. You know, it can still measure heart rate and time, and you know, can still do time-based interval training. But in terms of calculating stride length specifically, well, it wouldn't be any good for that. Perhaps there might be questions sort of about their use outdoors as well in relation to the strength of the satellite signal. It would be a fair question to ask how the accuracy of the GPS might be affected by satellite reception. In a paper by Witt and Wilson, however, they determined that the accuracy of speed determination was preserved even when the positional data were degraded due to poor satellite number or geometry. Certainly one limitation of GPS watch is where there's lots of tight corners. So if you're, you know, zigzagging back and forth a lot through tight trail runs, or even on a 400-meter running track, the tight curves there, the GPS watch just can't determine the distance accurately, probably due to the mathematical algorithms that are used and the smoothing out of the sort of peaks and troughs. Likewise, sudden changes in direction it can't keep up with. It's better suited to sort of linear and curvilinear trajectories, and you know, reasonably consistent acceleration, not too rapid changes up and down in acceleration. GPS watches work best on a relatively straight course. Witt and Wilson point out that errors increase on circular paths, especially those with small radii of curvature due to a tendency to underestimate speed. Certainly they're not suitable for recording distance and therefore speed on a 400-meter running track. It can take a bit of time to learn how to use a GPS watch. If we're just talking about sort of distance and time, then it's fairly straightforward. Just to press a stop and a start button, you can use it as simple as a stopwatch. But there are other features that have been mentioned earlier, and accessing all of those features and knowing how they all work, that can certainly take some time, especially for somebody new to, you know, that kind of detail on a running watch. For example, I demonstrate some of the sort of menu functions here, so that you've got the home screen. But of course, if you want to look at a little bit more detail and, you know, get into some of the other menus, there's quite a number of menus, and there's many layers and sub menus, and knowing how to find all of those and, you know, locate all of the key features that one's sort of after, it can be time consuming. But once you get the hang of it, there's a lot of detail that is extremely useful, and just, you know, having access to that kind of technology to measure improvements in performance or changes in performance can explain, you know, sometimes reasons of fatigue that the athlete might not have been aware of. It can be quite motivating because you can see that, you know, the performance is improving, and of course, you know, over time the watches will become even easier to use, and, you know, they'll be more suitable for even a wider range of athlete, recreational or otherwise. Of course, Moore's law applies to GPS watches as it does all sorts of technology, which describes the idea that transistor density is doubling every 18 months or so. So that just lends itself to, you know, more powerful watches, smaller, you know, lighter weight. Accuracy will improve. There's enormous potential for the use of GPS and GPS watches in particular in the field of biomechanics. So just to sum up, GPS running watches, they're sufficiently accurate for comparative purposes, and certainly in the context of the recreational athlete, which is the broader audience. They're fairly inexpensive, they're accessible, relatively easy to use, maybe a little bit of a learning curve if it, you know, when you first get to use one, but relatively easy to use, and can be used in all kinds of environments, so long as you've got a GPS signal, of course. Be mindful of using them in you know, situations where there's lots of corners, tight curves, for example, a 400-meter running track, or where you know, sudden changes in direction or acceleration might be determined by the course. Otherwise, they represent great value for money, especially with all the, you know, features that are packed in nowadays. So thanks for listening, and remember, no matter how slow you go, you're still lapping everybody on the couch.